Yeah, let's take a look at this one. We'll see what it's asking. So different symbols. Basically, if we're given a string, we want to find the number of different characters in it. Okay, so we look at this one, cabka, and the answer is 3. Now, you might notice, because maybe you looked at the problem and you thought, oh yeah, that's easy, I'll just do a dot length, right? That'll tell us the number of characters in it. Thing is, that doesn't account for repetition. Okay, so we want the number of different characters. How many different ones are there? Well, we're not going to count repetitions. So how are we going to do this? Well, there are a few ways. We could start by doing something like what we've seen before with our character count array. So a character count is just going to be an empty array for let I be assigned the value of 0, I is less than 26, I plus plus, character count dot push 0. Okay, we could do something like that, right? And then go through the array, go through the string. So for, we can even just do like we did last time, do an of loop, a for of loop for let character of s. And then basically just say let character code be assigned the value of character code at, we're seeing char like a lot of times here, but hopefully that's not too confusing. Okay, so it's going to be character code at minus lowercase a dot character code at, because notice that these are all lowercase letters, and so we can use lowercase a. We don't need to worry too much about it. But in case you're wondering about this, like why am I subtracting this? Well, I'm just trying to normalize the character codes, because by default, lowercase a, has a character code of 97. We don't want it to be 97. We want that to be 0. We want B to be 1. We want C to be 2. We want D to be 3, etc. So instead of that, instead of the 97, by taking away this, which is 97, we normalize it. We make it so that our character codes are going to be between 0 and 26. Okay, so then all we need to do is character count at the index of character code plus plus. So there's already zeros inside of those, and now we're just adding 1 onto all the ones that we find. So then we're going to return character count at the end of all that, and we'll see what it comes up with. Okay, so we got 2, 1, 2, and then a whole bunch of zeros. We've got 2, we've got 1, and a whole bunch of zeros. So notice the ones that aren't zeros, or the number of them that are not zeros, that's the answer. Whoops, just the 2 here. There are 2 of them that were non-zero. There were 3 of them here that were non-zero. Okay, so that's basically the idea. We want to look at like how many of these are non-zero. So yeah, let's do that. We'll say dot filter. And this is kind of interesting. I really like this. So num is what we have in these, right? We have a number representing how many times that character appeared. We want to say num is not equal to 0, right? That's what we're looking for. So actually, let's just run this for now, and we'll see what it comes up with. So now just the 2, 1, 2, like we were seeing before. Was it? Yeah, just 2, 1 for this one. 2 A's, 1 B. Okay, so basically, if num is not 0, we're going to keep it in the filter. But still, that's not answering the question, but it's pretty damn close, because look, the length of this thing is the answer. It's 3. The length of this thing is 2, which is the answer over here. So if we just slap a dot length on the end of this thing, then we're good to go. We're getting the right answers for all the visible tests anyway. Are we going to get the right answers for all the hidden tests? So let's just do a quick submit, and we'll see if we pass all those. Oh, and we do. Okay, so that's nice. We're on a roll today. It feels good. But we're not done yet. We've got to do some other stuff here. Now, something we noticed in a previous challenge just not too long ago was basically this over here. We found that, okay, if we're thinking about the way filter works, filter takes in a function which is going to act on every element in the array, and for each of those elements, the function is going to do something that'll return a Boolean. If that Boolean is true, it'll keep the element in the array. If the Boolean is false, it will remove the element from the array. So basically the idea is that we're saying, well, if num is 0, return false, remove it. If num is not 0, return true, don't remove it. But that's how JavaScript naturally works. That's how it typecasts a number to a Boolean. So if it's 0, it will be false. If it's non-zero, it will be true. So I don't need that part. And now this kind of seems sort of silly. You know, we're doing a filter that just maps num to num. It seems kind of weird, like almost like it's not doing anything at all. It's like an identity function, right? But the thing is, it actually is doing something. Importantly, it's typecasting it to a Boolean. We're just not being clear about that. We're not really explaining that it's doing that, but anyway, it is, so nothing to worry about here. Maybe it's better to put in the not equal 0 just for the sake of clarity, you know, for the reader. I actually think it looks kind of charmingly funny like this, so I'm going to keep it like that. All right, so what modifications could we make here? Well, I mean, first thing is, if you're trying to say bytes, like, you know, we could make that a 97 if you really want to. It's up to you. But anyway, we could also do something like this. So instead of creating the character account and, well, actually, hold on a sec. We found that this algorithm was working, so let's archive this algorithm. It's going to be good. We'll keep it fresh for later. All right. So there we go. We're going to retry this. And now basically what I want to do is I want to not use 2 loops, because I'm looking at this and I'm thinking, you got a for loop here, you've got another for loop here. Can we do it with one for loop? Yeah, we probably can. So basically the idea is that in this case, okay, first, in the case of this whole algorithm, we're looping through this one to create the character count array. Then we're looping through the string to fill up the character count array. Instead, what I want to do is delete that part so that we can just do this. Okay, so we're going to push in something that's maybe going to be a 0, but maybe it's not. So I'm going to say let count be assigned the value of 0, and instead we're going to push in count. So far this isn't doing anything different. So we'll say let character be assigned the value of string dot from character code. So this is just like this, like dot character code at, but reverse. So now we're going to do a string coming from a character code that's going to be a dot character code at. Some people might find it annoying that I keep using this whole thing instead of just writing the number 97. But I think it's nice. It's showing the reader where this whole thing is coming from. But look, if it's going to make you happier, let's do something like this. We'll say a, and right at the top, I'll say const a is assign the value of that. You know, just so we're not actually repeating a calculation here. So again, it's 97, but no big deal. Okay, so we're going to do a plus I. That's the character we're looking for, right? Something that's 97 plus whatever this I that's going from 0 to 26 is going to be. So if it's adding on 0, well, we're just going to get lowercase a. If it's adding on 1, we're going to get lowercase b. If it's adding on 2, we're going to get lowercase c, etc. And then basically our count, well, actually, you know what? I'm not even going to do it this way. I'm not going to start it at 0. I'm going to declare and assign it at the same time. And I'm going to say that it's going to be s dot split dot filter character equals whoops, I can't use that. I'll use I guess I'll just use an x, and I'll say x equals character dot length. Okay, let's break this down a little bit. So what is count doing? So first of all, it's taking s. S is a string to begin with. Maybe it's cabcub, maybe it's something else. But the point is, the split here is turning this into an array. So an array containing C, A, B, etc. And so it's taking that array and then it's doing a filter. It's saying, okay, all the characters in there that are the same as this character that we're looking for right here, how many of those are there? And that's why there's a dot length. And then we're just going to push in the count. And for the ones that happen to be 0, we'll disregard those. So let's see if this still works. And also, you know, let me know if you have any questions about what's going on here. I realize we're doing like quite a bit of stuff right here. Okay, that is still working, so that's nice to see. Now, I've said this in previous videos, I'm gonna say it again. I don't really like using split in these contexts because I find it's not self-descriptive enough. I like the idea of using array.from because it's showing we're getting an array from this string. It almost couldn't be more clear. Anyway, the point is, that's a lot nicer. Now, I don't know which one's better in terms of execution time. I don't know if like the time complexity is really bad on array.from. I don't know if the support is really bad. I don't know if you should be using it in production. There's a lot of things I don't know about this. But anyway, the point is I know that I like it. I know that it's pretty cool. If anyone has any more intel on that, definitely feel free to let me know. Okay, so we've got our counts here. Did I try running this? Is it still working? Yeah, it's still working. Okay, I might as well just delete that space there. Okay, great. So at this point, we might ask ourselves, which of these was the better algorithm? You know, was it better to use this one that had 2 loops or this one that just had 1 loop? And the answer might surprise you. This one's better. In terms of time complexity, in terms of how long it's going to take to run, definitely this one's better. And the reason is because it's looping through this, was just 0 to 26, so that's big O of 1 anyway. It's not going to change. The size of this is, okay, the amount of time it takes to do this, like these lines over here, will not depend on the size of our inputs. Even if we had a string that was 150 million characters long, it would take the same amount of time to do this over here. Now for this part, the same is not true. You know, if the string is really long, then yeah, this will take a longer time. So this will scale up according to the length of the string. So this would be like a big O of n, where n is the length of the string. Okay, and then the filter, well, this again is going to be big O of 1. It's going to be just like this because we know that character count as an array is only 26 elements long. So no matter what kinds of numbers we have in there, since it's only 26 long, it's not going to make this any more complicated. All right, now compare that to what we have up here. We've got an array, we've got a loop that goes from 0 to 26. So you might say, oh, okay, well down here when you said that there's a loop going from 0 to 26, you said, well, that's big O of 1. We don't have to worry about it. And I see that you're using my words against me. Now it's a nice try, but the reason it's not going to work is because there's some fishy business going on inside this loop. So yes, it's going to go from 0 to 26, but every time it does that, it's going to do an array.from, which actually, to be honest, like we should be doing something more like oh no, not like an a. We already have a r, so we'll say let r be assigned the value of this. In fact, we're not modifying that, so that should probably be a constant, I think, right? That should work. Right. There we go. All right. So yeah, maybe that's better because we're not actually recalculating that each time. Okay, so that made it a bit better, but still, we're doing a filter. If we're doing a filter, that goes through the array. So down here, we're looping through the array one time, right? We're looping through the string, I should say, one time. So if the string has 150 million characters, this, yeah, it'll iterate 150 times, so that's it. Here, yeah, we're going through the array, and that array is the string. So we're going through the whole length of the string. Let's say we're doing those 150 million operations, but then we have to do that 26 times. We're doing that for every single one of these. So as it turns out, this is the better algorithm for time complexity. Lo and behold, who would have known? Who would have known? Anyway, okay. Can we do this any differently? Maybe we're just not thinking about this the right way anyway. Maybe what we're doing here is overkill, because if you think about it, we're kind of taking these character counts, and the only thing we really care about is if they're 0. So maybe we don't need to worry too much about that. Let's try this. Let's make an array called used characters. Okay, and this is just going to be taking a look at which characters we've used. And then we'll run a loop for character of s, so basically just going through every character inside the string s. And it'll say if not used characters, not user, used characters dot includes character. Okay, if it's not already in there, then we'll say used characters dot push character. Okay, and then at the end, let's say return used characters. Let's see how that works, or if that works. We'll find out. Yeah, great. C, A, B. that's nice. But the thing is, again, we're looking for the length of that thing. Length. Okay, so let's try that out and we'll see if that works. Well, that's kind of nice. What I like about that is we didn't have to worry about char code at. We didn't have to worry about character counts or anything like that. We didn't split this into an array. We didn't have this 97 business to worry about. There isn't even a filter happening here. So if you think about it, a lot of these, well, both of these algorithms we're doing down here, a lot of the work we're doing in those, we're kind of undoing at the end. So this is nicer. I like this a lot better. Now I'm going to change it a little bit. So I'm going to say, first of all, because I believe includes is not supported as well as indexOf. So we'll say if indexOf this is -1, right? And that way we don't need to put the not at the beginning either. So yeah, let's try that. Will that work? Yeah, that works great. But I'm going to change it again. So I'm going to wrap this one up and we'll copy that because there's a different way I want to do this. Because basically we're saying, we've got this thing where we don't really care about repetition. We want to put something in it. And if it's already there, don't worry about it. This reminds me of another JavaScript object that we've talked about. And it's another new one. It's an ES6 thing. So again, use at your own caution, right? And let's see, we might need to look up the documents for this one because I'm not super well versed in it, but I'm pretty sure we can do something like this. Used characters dot add character. And then it's not going to care so much about that. So return used characters. I'm not sure if this is actually going to, yeah, it's not showing us that in the way we want to. But we could say like dot has and we'll say C. So for the first one, it should say true. Yeah, it has C in it because we used a C. But in the second one, no, we didn't use a C, so that's false. Now, what I'm not sure about is I don't think we can do dot length for a set. We could like typecast it to an array, I'm pretty sure, and then measure the length of that. But I think there's a different property for a set that we use. I think it's called size. If it's not, then we'll go ahead and look it up. But I think it's size. Yeah, okay, it's size. That's nice. This is getting pretty cool, especially because we can do something like this and, ooh, not bad. That's, yeah, I gotta say I like it. That's a nice algo. Yeah, that's probably my favorite one yet. Okay, nicely done, everyone. So we're gonna do one more thing here. In the previous two, in the other two tasks we did today, we found that we were actually able to represent each of them as one-line solutions. So maybe we can view that as a challenge and try to do the same thing over here. So I'm just going to wrap this in tinfoil real quick, and then we're going to try our one-liner. But before we do, I'll just do this. Probably best. And then uses ES6 though, you know, in case that's an issue for you. Okay. Now, of course, here's the thing, right? Like I talk about this idea of support, right? Like being able to use this stuff on the web, being able to use this kind of stuff in an app. And my understanding is that a lot of modern developers want to be able to use these tools regardless of the support they have. So they have these things that are called like polyfills or shims, like things like that, like that sort of have fallbacks, right? So if you're trying to use something that's not supported, then it'll fall back to a supported version of that. So this is something that web developers have been sort of dealing with for a long time because Internet Explorer. Okay, so let's continue with this. So basically what we want to do is we want to try to do this as a one-line solution. But I'm going to do it one step at a time. So I'm going to say we're going to convert string to array. And maybe instead of string, I'll actually just write s, convert s to an array. And then once we've got s as an array, we'll say something like find the number of non-repeating characters, or just find all non-repeating characters, and then we'll say measure the length, or how many are there? That's nice. That's very human friendly. And that's going to be it, I think. So we'll start with this. Convert S to an array. So we'll say let R be assigned the value, or we're not going to modify it, so it's going to be a constant. Constant array is assign the value of S dot, or actually the way we did it before was array dot from S, and we like that. It was nice. Okay, great. So now we want to find all the non-repeating characters. So we'll say let uniques. Let uniques be assigned the value of array dot filter, and this is where things get pretty neato. I really like this. So we're going to use both here. We're going to use the character, and we're going to use the index of the character. And what are we going to do with these? Well, basically, what we want to say is this, and this is kind of cool. So we'll say array dot index of our character equals I. So this is kind of weird. And in fact, I actually just want to return uniques here just so we can see what this is actually doing. So array just takes this, busts it up into an array. So it's C, A, B, C, A. You'll notice we're not seeing the C and the A, and it's because of the filter here. So the way the filter works is it's saying we've got a character, we've got an index of that character. So just to sort of show you what's going on over here, let's grab some cool colors. Let's make this a little thinner because I'm going to be writing down here alongside these. And we'll say we've got C, A, B, C, A. All right. And what are the indices of those things? Well, 0, 1, 2, 3, and 4. Okay. So basically the idea here is as it's going through with the filter, it's saying, for each character, we've got our index, right? So for the first one, the character is C, the index is 0. And it's saying array.index of character. Sorry about that. Here, let me fix it. Okay, great. So array.index of character. Well, what is that doing? It's basically saying, all right, where is the C? Oh, it's right there. So the index is 0. Now notice there is another C there, but that's okay. It doesn't care about that. Index of will always find the first index that string or character occurs at. And that's an important behavior. We've sort of talked about that a little while back and how there's kind of an alternative way of doing it, which we'll look at in just a sec. But the main thing is that index of finds the first instance of that character. Okay, so then we're basically saying, all right, well, where's the first C here? Well, that's right there. It's at index 0. And what's the index here? Well, we're on the 0th element, so it's 0. So the two are equal. 0 equals 0. Oh man, I'm not good at circling. I'm only realizing it now. I was so confident before. All right, so there we go. All right, so we're basically saying, in this case, for the 0th element was the letter C. And the index of C in the array is 0. So 0th element, index of is 0. So it matches. So it says this is true. We're going to keep that character in there. Boom. Great. Whereas with the next one, well, actually, I shouldn't say whereas, because it's still going to be true. I mean, it's going to look at this. It's going to say, what's the index of A? Oh, it's 1. And the index of this element was 1. Great. Next one. What's the element in index 2? It's B. If we do an index of, the first B is at 2. So that one's good. Now this is where things get interesting because we say, all right, what's the element with index 3? It's C. And if we do an index of, we search the array for the index of C, it would be 0. Is 3 equal to 0? No, it's not. So we're not going to include that one. And then we look at the last one and we say, this has index 4. The character is A. Array.index of A would be 1. 1 is not equal to 4, so we don't include that one either. So we just have the C, the A, and the B. Now something I should probably point out is we also have the option of doing lastIndexOf. And that's going to work just as well because, you know, if they're in there more than once, it's either going to match the first instance of them or the last instance of them. There's still going to be 3 things in there. So it's not going to make a difference whether we use indexOf or lastIndexOf. And if you're unfamiliar with lastIndexOf, I mentioned it in the video for task 32. So how many are there? So that's where we're just going to return uniques .length. Okay, so let's try that. And yeah, okay, good. That's working. It's passing all the visible tests. I would assume it's going to pass all the hidden tests as well. And okay, great. So maybe now we'll try to put this together, right? We said before we want to do this in one line, so let's try to do it in one line. Now, there's one thing I'm wondering actually, before we go any further. This is array.indexOf character, but could we have just done s.indexOf character? Like, does indexOf work for strings just as well as it does for arrays? And yeah, it does. Okay, so because of that, we don't need to actually use the converted version. We only need to use it here, which means we could just take this thing and put it in here. So then we're really doing 2 things at once: convert to array and find all non-repeating characters. Okay. And then at the end of that, we're just doing the length. So we could just slap on a .length onto that and just put our return right up top here. Return that, and we'll just space this out a little more. Okay, great. So, and find the number of non-repeating characters. Great. Boom. So, is that a one-liner? Yeah, it's a one-liner. It seems to be working. Is it the best one? No, I don't think it's the best one. I think this one is better. As it turns out, this one is actually not the best. There's a better way we can do this. So let's grab this. We'll take this stuff down here and we'll put it up here. And actually, maybe we'll just cut that and put it below this set one, just because I sort of want to keep these 2 together. So we'll comment that part out, and there we go. Okay, so this is where we were using set, right? And I mentioned this last time. It's one of these new ES6 things. So here the docs here on Mozilla. So basically set, it's the new type of object. What we talked about last time is you want to use a set when you basically don't care about repetition, when like repeated values are considered the same to you. Okay, so that's when we want to use a set. But now look at this. In terms of the syntax here, it's telling us something about its constructor. It's saying set, and then in the parentheses, we've got iterable. Okay, so that's the thing I want to talk about, the iterable thing. Because notice over here, we're just doing new set, and it's kind of like just an empty constructor over here. So maybe there's a different way we could do that. So when it says iterable, let's first try to understand what that means. So it's talking about an iterable object. Let's click on that, see what they mean. Okay, so it's saying an iterable object basically includes an array, a map, a set, a string, a typed array. So that's the thing I want to talk about now. So if we were to just say like return array.from s, this would basically just create an array from the characters in the string s. So there we go. There's Cabca as an array. So let's say something like this. Let r be assigned the value of array.from s. And then we'll say, yeah, I guess not much more to say about this. I'm going to get rid of this part because basically, if you think about it, we're creating an empty set and then we're loading it up with the things from s. Well, now we have s as an array, so I'm actually just going to say new set with an argument of array. So that as the constructor fires, so when it makes the new set, it's taking it from this iterable. It's taking it from the array that I'm passing as the argument. Okay, so now let's see. Well, what we found before is it's not that easy to look at like what a set looks like. If I were, let's sorry about that. If I were to do, actually, let's get rid of the dot size here, and this isn't going to be too interesting. Yeah, it's just doing that, which looks like an empty object, but I think it's just because it doesn't have a nice way of actually displaying what a set looks like. So we could say, you know, dot has C. I think we tested this before. So yeah, this one does have C. This one does not have C. So this is giving us an idea of like what's in the set. It probably has A and B as well. I don't know, we could test it, I guess. But the main thing that we want to do is we want to know how many things are there in this set. So that's where we're going to do dot size, which is a lot like dot length. So hopefully for something like this, I mean, it should be 3 because there are 3 different characters in here. And there we go. So that's a little easier. We don't have to worry about loading this up manually. We don't need to go through the entire string and then push each character in there. The other thing is this. I mean, look, when we were looking at what's an iterable, it said, yeah, it could be an array. But one of the other things in this list here is a string. So maybe I don't need to convert this to an array. Maybe I could just get rid of this and say S, you know, the string S. And is that going to work? Yeah, it works just as well. In fact, you know, you could argue that works better because it's one fewer line. In fact, look, used characters is just this new set S, right? So could we just pop that in there, forget that ever happened, and just run it like this? Yeah, we can. So probably best? No, I don't think so. I think this one is probably best.